Okay, so what I want to do now is talk a little bit about these boxes up here. These boxes are color-coded. This is the red graph, this is the red box, this is the blue box, this is the blue graph. And I'll set this one to be blue as well. So this is channel 40, this is channel 1. So we might want to do different things. We might want to know the difference in time between when the heart contracts, which is around about here, and when the pulse is felt on the end of your finger. So if we set this up to delta t and we drag this out, delta t is the time between there and there, and that's what we want to know, and it's 0.39 seconds. We might also want to know what is the heart rate. So we do that by measuring between R and R. These waves, as I said before, are the contraction of the heart, and this is the next contraction of the heart. So the beats per minute is reflected by 60 divided by this period of time. The computer calculates it for us because we set this box up to beats per minute. So it does the calculation and figures out what the heart rate is based on how big this box is. Be aware again, as I mentioned before, that if you do this and you're measuring delta t, you still get a heart rate, or you still get a beats per minute, because all it's doing is dividing 60 by this number. So what you sweep out has to be relevant. The computer just takes the information you give it. So you have to be intelligent in your selection of information. And the third thing we might want to measure is the height of this PQRS wave. It tells you about the electrical activity in the heart, so obviously that's going to be interesting to know. So we can sweep this out, set this to P to P, and it will tell us that 0.756 millivolts is how high this is. The amplitude of this is 0.756 millivolts. So we set it to 3 different pink channels, measured 3 different values up here. Notice I used delta t from the pink channel to know the duration from the pink channel to the blue channel. And that's because delta t is the x-axis, and it always is the x-axis. It doesn't matter which of any of your inputs you're reading. Delta t is always along here.